Okay, my friends, so here we are back for the last type of problem on optimization. So this is one where they're going to give you two rates of change. So here's another word problem, and I just want to walk through an example of what these will look like, but these are very common. You'll almost certainly see one on the AP test. So at time 0, there are 100 pounds of cement in the factory. Okay, so again, let's write that down. So it's saying F of 0 is 100. For the rest of the day, cement is produced at a rate of 2t rad t plus 1. So this is my rate in. And then cement is also leaving the factory at a rate. So again, we see the word rate, so we're thinking like F prime. This is my rate out. So we have to write an expression for F prime, the total rate of change of cement in the factory. So my total rate, I need to incorporate both of the rates of change. So we have the rate at which things are being added minus the rate at which things are being removed, my rate out. So my total rate is 2t rad t plus 1 minus 20. So that's saying at time t, if you wanted to find the rate of change, I would plug in that point in time. So for example, if part B is the amount of cement in the factory increasing or decreasing at time 3, well, we find the rate at t equals 3 is equal to F prime of 3, which would be, okay, and I just plug in, this is my total rate equation. So I just plug in there. So that's 2 times 3 times rad 4 minus 20. So that's 2 times 3 times 2 is 12 minus 20, so that's negative 8. Okay, so what that means is my F prime of 3 is a negative number, so that means that the amount is decreasing because my total rate is negative. If it was positive, of course, we'd be increasing. Okay, so now let's answer some other types of questions. Part C, find the amount of cement that was produced between 0 and 7. Does this question say anything at all about how much leaves? No, right? It doesn't talk about the total rate. It's only the amount produced. So we don't care how much is leaving or how much we start with. It just asks how much is produced using this rate. How much is produced from time 0 to time 7. So that's just going to become integral 0 to 7 of 2t square root t plus 1. Yeah, I should have said this earlier, but like the last one, you are going to need a calculator for these problems, almost guaranteed. So to do that integral, which you can do by hand, but trust me, it's not easy, we'll go ahead and do this integral on our calculator here. So I'll just go ahead and math 9 it. I'm going to integrate 2x times square root x plus 1. Okay, and I'm integrating x goes from 0 to 7. And that gives me a total amount that was produced of 115.1789. Okay, now part D of this problem. Find the amount of cement in the factory at t equals 7. Now, it's not saying how much is produced. We need to incorporate both amounts. And in terms of incorporating both amounts, I need to use the FTC again. Because if I'm trying to find how much do we have at time 7, I know how much we started with, and that's going to affect how much we end with. So it's saying that f of 7 minus f of 0 equals integral 0 to 7 of that total rate. That total rate, I'm integrating that f prime. Okay, so I need to integrate 2t rad t plus 1 minus 20. Not 20t, just 20. Because it says the rate is 20, the rate is this. So it's just the rate in minus the rate out. Okay, so what do we know? We know that f of 0 is equal to 100, so we'll just add that to the other side. And again, I'll just do this on my calculator. So I'm going to do 100 plus, and then I'll integrate. And I'm going to integrate kind of that whole different thing right there, that whole equation with both parts. And I'm integrating that from 0 to 7. Okay, so when I did that, that told me that my f of 7 turned out to just equal 75.1789. Okay, cool. So look at the difference, right? Part C asks how much was produced from 0 to 7. You just integrate the rate, right? That's all we did in here. But in this part, when we say how much do we have at time 7, that's a situation where you need to use the fundamental theorem because you need to incorporate how much we start with, and then we need to incorporate, what is my rate in, and then subtract what is my rate out. How much gets added minus how much is leaving at any given time. Okay, now this is going to be helpful to us on part E. Part E says find the min and maximum amount of cement between 0 and 7. When do they occur? And this strategy on the two rates problem is almost identical to what we did on the last one. So just like before, I need to go ahead and find my possibilities. So those possibilities, of course, are the endpoints. So that's t equals 0, t equals 7, as well as any critical points. So that's when my, okay, now for the critical points, this is a little different because the critical points are when my total rate is equal to 0. So what I'm going to need to do is I'm going to need to graph that total rate. So I'm going to need to graph 2t rad t plus 1 minus 20. So I'm going to graph this on my calculator as y1. Anyway, once I've done that, it should look something like this, right? If you just look from 0 to 7 for your bounds, it comes up, it comes up, and there's one critical point right here. And when you do second calc 0, that tells you you have t equals 4.54255. Okay, great. So those are my three possibilities. My first step is always. Now for my second step, like always, and I hope you're getting the sense that all these problems are the same. Because when you're finding any kind of max or min, you always follow the same steps. You find your possibilities, the endpoints, the critical points. And then all you need to do is just find f at each possibility. Now, of course, here to find f at each possibility, again, we're going to have to use the fundamental theorem. Because what I have is a rate. I don't have an equation for f, so I need to use I need to integrate the rate to get back to f. Okay, now I want to point out, we actually know two of these already. The problem told me that f of 0 was what? Told me f of 0 was 100. And then in part D, I was able to figure out that f of 7 equaled 75.178. Okay, so to help me answer this question, to find the max or min, I'm going to need to go ahead and use the same thing. So just like before, right, I'm going to use the FTC to help me find f at this possibility. So when I find f of 4.54255, well, that minus f of 0 is equal to the integral from 4.542, boring, okay, 55 of that total rate. And again, this is like you've seen before. You have the same initial conditions before it. This is still just minus 100. So you just do second enter to bring that back up, and then all you have to do is change the bounds. Right, so when we change the bounds here, now I'm going to 4.52455. Okay, and that's going to give me an f value there of 50.11833. Okay, now let's answer the question. The question asks for the max and the min amount. And this is kind of like the third applied step, is make sure you answer the question properly. Find the min and max amount. We have 175.50. Okay, so this is going to be my max amount. So I started with the most at the beginning of the day. And then at the end of the day, I had 75. In the middle, at this point in time, I had a minimum amount of 50. Okay, so a similar strategy to the last video, in that we're looking at critical points, looking at endpoints, we're using the FTC. The new key on these is when you have two rates, going with that total rate to just equal the rate in minus the rate out. So how much is being added minus how much is being subtracted. And that's really the key on all of these problems. Okay, well, thanks for watching, guys. Bring me questions to class. I'd love to help you out with these, and I'll see you soon. It's good stuff.